Hi everyone, my name is Zoal. I recently completed Metis Data Science Bootcamp in San Francisco. For the past 4 years, I worked as a mechanical engineer at a startup company designing electric marine propulsion system. Working at a startup really gave me an opportunity to wear many different hats and learn new things to solve problems. And as a lifelong learner, I am intrigued by how you can leverage data to understand and find solutions to the problems in many different industries. And that's why I decided to attend Metis to gain these new special skills. And today I'm going to be presenting my passion project at Metis on training an object detector using TensorFlow API. So last summer, I met this camp counselor who organized summer camps for the blind kids. He mentioned that it was challenging to do water activity with them because of safety concern. So I built this electric inflatable pool float so that they can ride around on their own and enjoy being on the water. So I have this ultrasonic sensor to detect the obstacles around the floats. They are low cost, but they're very unreliable and easily damaged by the water. So the kids will confined to just riding around in the pool. So I want to design a better detection system by implementing computer vision. And so for this project, I train an object detector that can detect other pool floats and kayaks, and then also tell the location of these objects relative to the kid's position. So I collected images from Google using Selenium, and then also downloaded some Kaggle data sets. And I labeled these images using the label IMG. And I trained and evaluated the model in TensorFlow API and Python. And I used OpenCV and Matplotlib for visualization. I had about 500 label images with the two classes of pool float and kayak. So my initial data set were mostly the stock photos from Google. So they didn't have that many variations in size or difference, size and orientation. So my initial model wasn't able to identify these objects from different angles. So I updated this data set by collecting more images that are in realistic surroundings and that have different sizes and orientation. So this greatly improved my model, and my model was able to detect these objects from different angles better. So the model I use in this project is called Faster Region-Based Convolution Neural Network. It is the combination of feature network, region proposal network, and detection network. So first, the image is passed through the convolution layers or feature network to extract the feature maps. Then region proposal network take the feature maps and propose bounding boxes that might contain an object. Then the detection network takes the input from both region proposal network and feature maps to determine the final class and location of the object. And since we are predicting both the location and class of an object, we use average position over range of IOU to evaluate the model. IOU is a measure of how well the predicted bounding boxes match up with the ground truth. So for my model, when the IOU is about 50%, average position is 0.9. When IOU is increased to 75%, average position goes down to 0.66. And also the average position for detecting large objects are twice as much as detecting small object. So as you can see in this image, the model was able to detect the larger kayaks with a confidence level of 99%. But for smaller kayaks, it either fails to completely identify it or detect the kayaks with much lower confidence level of 70%. And here's another example of the model detecting both, large objects of the both classes with a high confidence level of 99%. And from the bounding box coordinates, we can also extract the location of the object in the image. Here, the model is able to detect whether the object is on the right side of the image or the center or the left side of the image. And we can use this information to provide the kids with the location of the object relative to the position. So the model is very good at detecting large objects, particularly flamingo pool floats. And then it can also provide the location of the object in the image. And this information can be used to alert the kids where these objects are relative to their position, and so that they can navigate better and venture out farther in the lake on their own. So in the future, I like to include more images and classes to improve the model. And I would also like to explore other models that can be implemented on Raspberry Pi and Arduino so that I can test this out in the real setting. And thank you very much.